Oh why is my motorboat going so slow? I'm waiting for my little red mark to come back around so I can put the half nuts back in and chase the thread. Here's what I would call a normal dial, what they call a 4-inch travel dial. And you notice it's traveling a little bit slower yet. I'm waiting for my little left turn light bulb to just burn out as it comes around to the revolution. You notice when we lock it in, the dial stops turning. It's locked in the thread, can't go anywhere. When we kick this out, it starts turning again. What that dial is actually doing is tracking the location of the saddle and the length on the lead screw. It's a measuring device for practical purposes, and it's telling us the angle of rotation. What if this dial could be used to lock it in here, 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 whoops, let's get it back, there, there. With a 12-pitch thread, as it turns out, you can lock this dial in 16 places. And it doesn't make any difference where this saddle's at, 16 places, and it will register with a 12-pitch thread. It's always in registration. It can't get out. So any place you can close the nuts, you can thread that 12 pitch. Well, what's the deal? Well, we work a fraction, but first, the threading dial, once it came into wide use, it pretty much put an end to reversing the saddle, unless you had a really strange lead you were cutting, or metric. I'll get into a little bit of that later. And really the only machine that still could thread fast by reversing the saddle on a Norton would have been a hard hinge. Handy's had it, Pratt and Whitney had reversers, but if you did it at high speed, it was pretty hard on things, and plus they wore their nuts out kind of quick. But if you can figure the thread dial out and how to do it, you can speed your operation up really quick. And if your neighbor doesn't know how to do it, you might be able to take his money. So we'll get into this a little bit. Well, here's a little tease of part 2 where I work the chase dial calculation and approve it with different taps. The rest of the video goes through sorting out different dials, how the gearing works, what's in the quick change, and an example of setting up change gears for threading. Okay, what's this nonsense all about? As I just showed you, this dial, I'll take it out, basically tracks distance. And the gearing is what's in charge of turning that lead screw down there in the proper relationship with the spindle. And it works in length. Anyway, I know it doesn't make sense because you got gears they work around, but it all interprets. So, how do you find the teeth on your dial? Well, here's another dial, and it's off basically a 6-pitch machine, and it's a legal dial, and it's what I would call a 4-inch dial. So on a 6-pitch screw, that's going to travel an inch, and I'm working around my finger, 2 inches, 3 inches, 4 inches. On 6-pitch, to go 4 inches, I need 24 teeth. So you can take your dial off and count them, or you can check it with travel. And the odd thing about the 6 pitches is when you have a normal 8 division dial, a 6 pitch will lock in here, and then lock in here, and that distance would be 1/2 inch right there. And it'll lock in here, here, and it's basically .1666 inches. So you very quickly get the idea that a number box will get you in trouble. Better to work with fractions. For a 4-inch travel, you basically lock your saddle and just mark your tailstock down here, and then take it loose, and you travel one whole revolution of the dial. The GoPro here is kind of shaky, I know, I apologize. And then you just marcus again, get that stuff out of the way, and measure. And I just happen to have a 4-inch scale. As you can see, that little fellow's 4 inches. So I know it's an inch between each numbered division, and it's 4 inches on the dial. Oh, machines will generally have something that looks like this on them. You'll see they won't have the 4-inch equals 1 revolution of the chase dial, but they'll have even thread, any line, odd thread, any number line. Now, any line on a legal 4-inch travel dial means it's every ½ inch you're in registration. And an odd threader, that odd by definition, if you got 9 threads or 11 inches, it takes it 1 inch before it starts over again. So you got 1 to 9 and then it starts over again. So your gearing's in registration possibly several times. However, you still have to go with the 1-inch registration. Your half threads, well, they've got to go 2-inch registration, or 1 and 3, 2 and 4. Quarter threads have a 4-inch registration, so you've got to go to the same number on a 4-inch dial. And usually you'll see something like moldable of lead screw anywhere it locks in the dial. Well, that's what I just did with a 4-thread cutting a 12 pitch. It's an even moldable of the lead screw, so you can't get the dial wrong. I'm also used to looking at dials that look like that, and that would be old-timey change gearing. I'm going to explain that again. This would be new-timey quick change gearing, because to get confidence, at least I feel, you ought to know how threads are cut, old-timey and new-timey. Well, and let's go over here just a second. This guy, let's take him and lock him in. He's going to lock in over here somewhere. There he locked in. And let's set our scale. And unlock it. Then travel this dial 1 revolution. And I'm on 2-inch. Well, from my rule from threading, that you got ½ inch for even, 1 inch for odds, 2 inch for half threads, I can cut all of those, but I can't cut a quarter thread. What's the deal with a half thread anyway? Let's go over here. This actually shows, let me get my finger here and look at everything all at the same time. Here we got 4½ thread. Well, actually 2½ is still a thread that you find on UNC for 2 1/4. It used to be 2 and 2 1/4, but I think it's just quarter now. It also shows 4 3/4, which is a quarter thread. I can't cut that on this machine, but I could on the LeBlanc. In fact, the LeBlanc cuts 8 threads, but it only resolves to 4 inches, so you better match mark. That's a different subject, because I can only track 4 inches of the saddle. Here is the correct thing to do to figure out the nut. You put your threads per inch to cut, your lead screw threads per inch, you reduce it to a whole fraction with whole numbers. Reduce it to least common denominator, whole numbers. You take the denominator, which is your reduced lead screw TPI starting. We'll work this out later. And then underneath of that, you have to put the number of teeth in your chasing dial. That will give you a fraction of the dial rotation. And when you have 8, if you notice those dials are marked in eighths or quarters or whatever, they're a fraction, and that's how it's done. Sorry, I got a little bit of sniffles. Another thing you'll notice, we just well use this machine for looking at something. And your quick change works like old-timey machines. It's got a simple gear. This box in C is 1-to-1 with a spindle. When we go to this side, we multiply it by 2. Go here, multiply it by 4. We're increasing the speed. That's going to cut coarser threads. We're back to 1. Now we divide it by 2, half speed. We divide it by 4, quarter speed. So if you look, generally in the middle, on a box like this, those are the gears that are on your tumbler. And you also look, and you will see 16 divided by 2, and divided by 4, and multiplied by 2, and 4. And you'll also notice that the reason that you have 19 threads, there's where you get your quarter thread. And 18 threads, half of that's 9, quarter. So these are real simple gearing, is how they work. And spend a little time with your number box, you can figure out exactly what the gearing is in the lathe, which is what we're going to do now. Walk over here, get this stuff out of the way. This is a diagram of old-timey lathes. You have your spindle, and then you had a reverser mechanism and a stud. And then you had your driver, an intermediate, and that screwed right onto your lead screw. It all hooked together. And your intermediate, you could put another gear, and then you do compound gearing. Your quick change, your spindle or your stud is connected inside. It may or may not multiply or divide. Doesn't matter. You still work out the same. It'll have an intermediate, then it'll have a driven that goes into the quick change. These also, often if you've got a tool room lathe and you can do some weird stuff, like work to a lead instead of threads per inch, we'll have a set of gears and you'll have spacers between the gears so you can do compound gearing. We're going to show you how to figure out the gears. Old-timey lathes, the good ones, came with a set of gears that went from 20 to 120 teeth in 5-tooth divisions, so you come up with 21 gears. And to figure out your ratio, you put your lead screw, you can't get away from the lead screw, over the number that you want to cut. So we've got 4 thread per inch lead screw on the LeBlanc. We have 12 threads per inch we want to cut. We reduce that fraction, it comes up to 1/3. Generally you use the smallest gears that you can find in your set, 20 being the smallest, 60 being the complement to get that gearing. You could use 30 by 90 or 40 by 120 and you'd be right. And compound gearing, may or may not show that, but it works much the same. first intermediate to the second intermediate to the output. Anyway, we figure it by driver teeth over driven teeth equals lead screw turns over spindle turns. You notice these just switched. Anyway, it stays the same, which equals threads per inch on the lead screw over threads per inch on the work. Simply stated, that is drivers over driven equals the threads per inch on the lead screw over the threads per inch to be cut. If you are cutting pitch, since pitch is 1 over the thread to be cut, it's the pitch to be cut over the pitch of the lead screw. To solve that one right there, we use this fella. Now I'm going to get all this nonsense erased, and we're going to work with the illegal dial and show how to solve evens, odds, multiples, and everything. It's a fraction, it always works the same, but I expect you're going to want to see somebody prove it. So we'll get on with it.